Okay, good evening and welcome to today's session. So, maybe before we proceed further, it is good if we have a recap of what we learned yesterday. And I'll just be picking a few team members, maybe just to give us whatever you learned. It should. It is not a must that it is exactly what we like what I mentioned or what was in the notes, but the general maybe knowledge that you are able to gain. I want to start from Peter. That's Peter Simon. If you are in a position to speak, maybe you can just tell us anything that you learned during our yesterday session. Good evening. Okay, thank you so much, Peter, for that. What did we say? I'm coming back to Peter with regards to the last section, that is making decisions. Like after you have analyzed, you now interpret for decision making. What did we say about it? Like in terms of communication, like communication of the results. With what did we say about communication now of the results? Mhm. Okay, presented through a report, yes, but there's something I said about the report. How should the report be? Okay, maybe I can just assist. We say that the report should be very simple so that anyone, even without the data analytics and data science knowledge, can be able to understand and make, of course, decisions. Thank you so much, Peter, for that. Um, yes, Elizabeth. Tableau and Power BI. Yeah. Okay, thank you so much, Elizabeth. Uh, you have introduced the concept of the two major types of data. That's the traditional data and big data, or the modern kind of data. And we looked at the how they are structured and so on. So that one leads me to something else. Towards the end of the session, there was a question asked by Melas on where I remember he asked very well that when it comes to traditional data, it is stored in relational databases. What about non-traditional data or big data? And I was able to respond to that. So maybe back to Elizabeth, because you have introduced that. Do you remember where we store non-traditional data? Non-traditional, which is called big data. Sorry, sorry, data lakes. Data lakes. Yes. Yeah, thank you. We mentioned about data lakes. Maybe we can have any other person to just remind us what we looked into yesterday so that we can start our session for today.
Yes.
Yes, Joseph?
When we're also looking at big data, we said it can be various formats, structured, semi-structured. Then I think we're able also to classify on how maybe it is characterized by the three different forms of how it is, what characterizes big data.
Yes, sure. So we looked at the characteristics of big data, and we looked at the three main, which was velocity, which refers to being transmitted uh, uh, with a high speed. We looked at a variety because of various formats, and we looked at voluminous, but I also added veracity uh, as part of those characteristics. So maybe the last one before now I can start. Uh, anyone who has learned something very new and unique that you didn't know, maybe you can assist us. Sorry, Joseph, are you still? Okay, okay, thank you. Anyone who learned something unique yesterday? Yes, Chanai? Yes, sure. So we talked about uh, no worries. We say that yes, there's a difference between data science and data analytics, but we say that data analytics is a subset of data science, and they complement each other, meaning that you cannot be a data scientist if you don't know data analytics. So thank you all for the highlights you have given. Maybe now we can look at what we are supposed to cover today. Let me share my screen. Okay, so after looking at the types of data in terms of traditional and non-traditional, the next question that we want to ask ourselves that what do you do to data? What do you do to data? So before we answer this question, we have two scenarios here, and I want you to follow keenly, and I'm looking forward to your contributions. So imagine the following scenario, that you are an analyst for a large company and your manager approaches you with the following request. So the request is that we need to consider client satisfaction in the next quarter so we can predict churn rate, oversee the process and come up with some numbers. So basically churn rate, what it means, let me give an example, for instance, of Netflix. Uh, Maybe let us assume that we have been subscribing to Netflix monthly. Then after some time, some of us start dropping. So the rate at which we are dropping, when it is transformed into a percentage now, is what called churn rate. Like you stop consuming a certain product or a service. So you have been told to oversee the process and come up with some numbers. Or the second scenario is that your manager tells you that you have an enormous amount of customer data from the previous quarter. Then they tell you that can you oversee the analysis and deliver an approximation of churn rates for the next quarter. So let me repeat the two scenarios. The first one, you have been told that we need to consider client satisfaction in the next quarter so we can predict churn rate, oversee the process and come up with some numbers. The second one is that we have an enormous amount of customer data from the previous quarter. Can you oversee the analysis and deliver an approximation of churn rates for the next quarter? Like, it is a question that have been asked based on the two scenarios. So give yourself a minute to name the difference between the two scenarios. Let me sorry, there was a blackout that affected my Wi-Fi a bit, but I'm back. So I think when I dropped, I was explaining the two scenarios. So I was giving the first scenario, and I hope I'm not breaking off because uh, because of that, maybe you will not find me in case. So imagine that the following scenario, you are an analyst for a large company and your manager approaches you with the following request, that we need to consider client satisfaction in the next quarter so we can predict churn rate, oversee the process and come up with some numbers. The second one is that we have an enormous amount of customer data from the previous quarter. Can you oversee the analysis and deliver an approximation of churn rates for the next quarter? So we have those two kind of scenarios. So give yourself a minute to name the difference between the two scenarios. Any attempt? Anyone who have understood the two scenarios? Just an attempt. It is not a must that you are right. Any attempt?
I'll try.
Yes, yes. Yes.
Yeah, so for me, what I'd say is that the first scenario deals with more with the since it's so prediction deals with more with the data science aspect of it. And the second scenario is on data analytics because you already have the data and what you can do to analyze and give an interpretation of what in the next quarter will be that will be better.
Okay, thank you so much, Donald. According to your view, a good attempt. That the first scenario is more of data science, you don't have the data. And the second scenario is more of data analytics because already you have historical data and so on. That's a good attempt. Any other person? Any other person? Just a trial. Okay, let me intervene. So, yes, Chanai.
Okay, thanks. Thank you, Seth. So the second instance, what I can see, the manager is requesting the analyst to make the analyst is requesting for the individual to maybe investigate the patterns of the customers in the channels. And then in the first instance, asking for the data predict to the pattern. So it will be the first, the second place, the first and the second place.
Okay, thank you. A good attempt once more. The basically what is coming up is the difference between data science and analytics. But maybe what? Yes, Elizabeth. Okay. Thank you. Okay, okay. Thank you so much, Rebecca. Sorry, Elizabeth, for that. Maybe I can give now Rebecca to close so that we continue with regards to your observations. Yes, we can't hear you. We can't hear you. Rebecca, you can unmute. Maybe you are speaking on mute. You can leave and rejoin once more. Okay, for Rebecca, she thinks that both are data analytics. So before even I move to the next slide, you see in the first case, there's no ready data in the organization that what this person is supposed to do maybe is to conduct a survey to collect data. But in the second case, there is already data in the organization that is available. So that's the main difference between the two scenarios. The first one, there is readily available data. The second one, there is readily available data, and the first one, we don't have data that's available. But thank you, team, that we have given various views according to how we have been able to interpret uh, the statements. So the main thing we are looking here is that there's no data and raw data. The first one, we don't have data. The second one, we have data that is raw. The raw data is data that cannot be used to make decisions, because you see the manager could not make a decision until a further analysis is done by the analyst. So yes, there was data, but the data was in a raw format that cannot be used for decision making. So that one leads us, because you have seen no data, raw data. Yes, there was data, but it could not be used to make any kind of decision. That one leads us to what we call pre-processing, or what we call, in most cases, if you have ever had data pre-processing. So regardless of whether a data scientist is given just collected data, or they have to go through the gathering process themselves, the data is going to be in raw format. So as you collect data, of course, maybe you can use surveys, or you can use other automatic data collections methods like the cookies on the websites and so on. Like, you see, when you visit various websites, you are being told like to accept, mostly we have pop-ups that do come with regards to the cookies. So once you accept, they are able to collect some of your data and so on. So when we are talking about raw data is untouched data that need to be converted into a form that is more understandable and useful for further processing. Yes, this data cannot be used for making any decision, but it needs to be converted in a form that is more understandable, like so that anyone can consume it to use for various analysis. So making it to be in a format that can be understood does not mean that an analysis has been conducted. Let me give an example. Like, you can have data that has a lot of columns and rows. Maybe let us say 20 columns, 30 columns, and so on. And maybe I'm interested in only 5 columns, or for the team, we are interested maybe in only 5 columns. You see, let me take an example. Maybe when even using Excel, the basic data analysis and science tool, is that you see, when you have a lot of columns and rows, you need also to understand some shortcuts, Excel shortcuts, to be able to navigate easily. So what happens in such cases is that not everyone in a company or an organization is proficient in such kind of skills. So it means that we need the data to be put in a format that can easily be understood. So this process of now converting this raw data in a form that is more understandable and useful for further processing is what you call data pre-processing. Is what you call data pre-processing. Is a form that you are trying now to convert your data into a way that can easily be understood. So when we are talking about data pre-processing, we have common data pre-processing methods. We have common data pre-processing methods that are available. So the first one, the first data pre-processing method is called class labeling the observations. So in this case, you arrange data by category or labeling data points to the correct data types. For instance, for traditional data, it can be either numerical like when you are talking about numbers, maybe your phone number is numerical, your age is numerical. Then when we are talking about categorical, maybe your gender, either male or female, your country of origin is categorical, and so on. For big data, you can rename as either a text, a digital image, digital audio, and so on. So that is what you call class labeling. So with this, it means that this data has been pre-processed in a way that it can easily be used now for further analysis. The next common step of data pre-processing is what called data cleansing or data scrubbing. So doing data cleaning, mostly you deal with inconsistent data, such as maybe misspelled categories and missing values. In fact, later along the way, rather, you will be working on, like for instance, you see, based on experience, it is rare to get clean data. In fact, most of your time you will be spending as a data scientist or analyst in data cleaning process. We spend a lot of time. Of course, organizations need to put measures to ensure that, but it is very rare to get that any kind of data in an organization is clean. And later, I'm going to take you through the step of ensuring data quality assurance in an organization. So you need to deal with missing values and so on. Maybe later in machine learning, you learn, for instance, if missing values are not so many and they are numerical, you can calculate maybe the mean and replace them with the mean and so on. So you look at various methods of dealing with that before you proceed for further analysis of your work. Another method is what called data balancing. So if the categories in the data contain an equal number of observations, they may not be representative of the population sometimes. So data balancing methods like extracting an equal number of observations for each category and preparing that for processing to fix the issue. So mostly this one happens like, okay, I don't have the actual statistics in this class, how many females and gents are here, but let me give an example. Let us say you have maybe you want to build maybe a model, a machine learning model, or to do an analysis. Okay, mostly that is in machine learning, and you find out that your variables that you are going to use, maybe in terms of gender, we are having 80% male and 20% female. If you proceed with that analysis as it is, it will not give you correct predictions. Why? We call them in balanced kind of data set. So you need to do further what we normally call standardization and other ways of balancing your data and so on before further analysis. So it is very important to do so. Another one is called data shuffling. In data shuffling, you rearrange data points to eliminate unwanted patterns and improve predictive performance further on. So, uh, for instance, this is applied for example. There's an example here that I have given. For example, if the first 100 observations in the data are from the first 100 people, maybe who have used our website, the data is not randomized and patterns due to sampling emerge. So you see, when you are doing, for instance, an experiment, a good experiment, even when you are doing sampling, maybe you want to test something, a product, a new thing that you have built and so on, it is always to do some kind of randomization. Like even among us in this class, it should be something random. It should not be that all of us should be part of maybe those people who are testing the product and so on. So you need to do some kind of shuffling of the data through randomization. Another one is data masking. This one is very, very important. Data masking aims to ensure that any confidential information in the data remains private without hindering the analysis and extraction of insights. And therefore, when you are talking about masking, it involves concealing the original data with random and false data. And this one allows you, as a data analyst or scientist, to conduct your analysis without compromising on private details. And this is a very, very serious area nowadays. Almost all countries, of course, we will be discussing later, I think maybe next week, on data privacy and governance as part of this training. You see, this has become a very serious issue. Many countries are implementing data privacy measures and regulations. The recent one I saw, Nigeria, I think so. Kenya has it already, and many other countries and so on. So, because, and also I'm very sure since this session has many corporate students, I think these are some of the regulations that you are already aware in your organizations, so that you don't try to, you need to put measures or interventions to ensure that the data is being handled professionally without without revealing any kind of information that like revealing private information without consent. So data masking, you see, for instance, if I want to analyze your ages, like I want to get the average age of my students, I don't need to know your names. So when they share that list with me, maybe they just put student 1, student 2, student 3, and so on. That one will not prevent me from conducting what I want. That is, for instance, to get your average ages and so on. So this data masking is something very serious, and organizations need to be keen and implement it. So those are some common data pre-processing. methods available in the organizational when handling data. So now that one takes us to another area. We have seen that data pre-processing is preparing data for further analysis. But before that, in an organization, you see, if you have employed data engineers, data scientists, and so on, it doesn't mean now that you don't have to put interventions because you have already employed someone who is going to do that work and so on. So that one uh, leads us now to data quality assessment. So the question here is that, does your data measure up? If you look at your organization, like the data being handled, does it measure up? So when you are talking about data quality, it refers to the suitability of data to serve its intended purpose. So it is true that many companies have been struggling with the issue of poor data quality for a long time. And it is not just about the cost of errors, but also about the lost opportunities that can come from inaccurate information. So just imagine that you want to make a decision and the data that has been used is inaccurate. So you can just, or you are building a machine learning model and the data available is inaccurate that you have used to make that decision. You can just imagine the amount of financial loss that it can lead to. So measuring data quality in an organization involves performing data quality assessments to determine the degree to which your data adequately supports the business needs of the company. I want to I want you to like to um, try to like understand this point, the second point very well, and even the first one. Like, in fact, if you check at the first one, you look at like the question, sorry, the question, does your data measure up? Like, the data that is available in your organization, does it serve the intended purpose or not? So that one leads us that a data quality assessment, what we abbreviate as DQA, is a process that can be used to assess the quality of a data set, and the data quality helps in identifying where we have gaps in the data, and these gaps can be filled by data providers and so on. And therefore, the importance of data quality assessment is that it helps organizations improve their data quality and avoid costly mistakes. Another thing that this one helps the organizations, it helps organizations make better decisions by providing insights into how their data is being used. So therefore, if you understand the strengths and weaknesses of your data in your organization, of course, it is, you can take the steps to improve the quality. Sorry, I don't know if there is a question.
Yes, sir, I have a question. Sorry for interrupting.
Yes.
So, on the third point, you have said that the essence of data quality assessment is to identify gaps if you feed it by data providers. What do you mean by data providers?
Okay. A data provider can be the organization itself, or can be, like, for instance, in an organization, organizations have internal data, right? So if the organization has internal data, still it is a data provider. The second case, for instance, let me say maybe you are doing consultancy and someone, maybe you are working in an organization that does consultancy, or you are doing as an individual. So if you have been given data, then again that person becomes a data provider. So it is almost like in Kenya we have what called data controller and processor. Someone can both be a data processor and controller. For instance, processor, a controller means that, for instance, you collect data and keep it. A processor means that you receive you receive external data, like you process data on behalf of others, something like that. So so a data provider in this case can be the organization itself or a third party. Yeah. Okay, thank you. So what we can say, that data quality assessment can help organizations improve their data quality and avoid costly mistakes. Also, it helps them make better decisions by providing insights into how their data is being used. Of course, I have said that if you understand how your data looks like, you can put initiative to improve the quality. So we are now going to look at, because the next question is that yes, we have said that it is important, but maybe you are asking yourself that how are we going to do an assessment as an organization to know the quality of our data? So to do this, we do by measuring futures of data to see if they meet what we call defined standards and so on. And we have some common data, particular features that are looked into and so on. That's where we are moving. So we have some of the metrics of data quality. These are some of the metrics of data quality. The first one is completeness. When we are talking about completeness, it refers or it relates to whether all required information is present in the dataset. Like in your dataset, is all required information present or not? For example, if the customer information in a database is required to include both first and last names, any record in which the first or last name field is not populated is marked as incomplete. And therefore, the metric that is used in assessing this dimension is the percentage of records that are complete. Like in that column, I'm going to look at it maybe and say that out of all the given observations, only 20% are complete. That's the metrics that I'm going to use to measure. The next one is validity. So data is considered as valid if it matches the rules specified for it. So for instance, we are talking about the rules that are such as the format of the data, maybe the number of digits in the data, types of data like strings. Strings is like character, your names and so on. You will learn all this later. Um, but an example, let me just give an example to enhance understanding, because I don't want to go so much technical now on the types of data set, the integers, the floating, the strings, and so on. But for example, a telephone number field that contains the strings, like let me highlight, I don't know if I, sorry, I think, yeah. So, like, You see, there's a phone number here which is in double quote, in single quotation. It is 1809 Oak Street. You see that one is not valid because a phone number cannot contain both what? Numeric and a character or strings. This is not valid. How do you measure it now? The metric for this dimension is the percentage of records in which all values are valid. So you look at, out of all the records, how many are valid. The next one is time, that's timeless. So this one, it relates to whether the information is up to date for the intended use. So what it means when you are looking at this metric is that uh, like maybe is the correct information available when needed. For instance, if a customer has notified the company of an address change, but the new address is not in the database at the time maybe billing statements are processed, then that entry fails what you call the timeless test. Because they were notified this has changed, but that one has not been updated. So at the time we need this data, we find out that it is not up to date. So the metric used to measure this is the difference between when data is needed and when it is available. So the difference between the two is the metric used. Another one is consistency. A data item is consistent if all representations of that item across the data stores match. For instance, if a birth date is entered in one system, maybe using the US format, and it is imported into another system using maybe a European standard format, that data lacks consistency. It is not consistent. Then the last metric is accuracy. Like when we are talking about accuracy, you are looking at the records, like were they properly captured? Like maybe if every customer maybe was paying a minimum of 1000 USD and we have a value below that, then it means that data is not accurate and it cannot be used for decision making. Sorry. And uh before I go further, or I give you room to ask questions because we will end here for today, there's something I want to show to you, a sample of data quality assessment report, so that you see maybe as an organization, as an individual, how do you prepare such kind of a data quality assessment report. Yeah, let me just share that as I'm waiting. I hope you can see my screen. Is my screen visible? Yes. So this is just an example. Um, you are addressing the analytics team. Maybe you have been hired as a consultant, and it is a report to the analytics team, YY company. The report was on data analytics approach, and it was done by John Business Intelligence Analyst AFRI CDSA. So this report had an introduction, data exploration, model development, and interpretation. But we are not going to go to other steps because we haven't yet covered in this class. But let us look at the address problem and the content to be analyzed that this company wanted. So this company, YY or that's Sprocket Limited, is a medium-sized bikes and cycling accessories company and is working on how they can optimize their sales. The company has provided 3 datasets. The first one is customer demographics. The second dataset was on customer addresses, and the third was transaction data in the past 3 months for analysis. So the main objective of this company is to draw useful customer insights which will help them optimize resource allocation for targeted marketing from the analysis. So the content to be analyzed was the past 3 years bike related purchases by gender, old and new customers job industry category distribution. Old customers is like repeat customers, like a customer who comes, returns severally to purchase a product. So old and new customers age distribution, wealth segment by age for old and new customers, number of cars owned and not owned in each state. Those were the content to be analyzed. So the first thing is what called data exploration. So in this data exploration, you do assessment of data quality and completeness in preparation for analysis. Before you do any analysis, it is always good, of course, some people might ignore sometimes, but it is recommended you do a data quality check before you proceed with any kind of analysis. So we have items that we have looked at: accuracy, completeness, consistency, relevancy, validity. So the first on accuracy, remember there were how many data sets? There were 3. The first one was on customer demographics. So the issue, okay, the objective of this, I just want to show you the format on how to input it. That's why I haven't showed you the data set. So for instance, in this customer demographic data set, age column was not included. On the customer addresses, it is blank because it was there. Then on transactional data, profit column was not calculated and it was supposed to be there. So the customer demographic and transactional data had accuracy issues. Secondly, was on the completeness. Like the last name column has blank cells, the job title column had blank cells, and the customer identification was not complete. The same, the customer addresses dataset also had the customer ID column and it was not complete. The transactional data also, the online order column has blank cells and so on. So basically, the purpose of this, I just wanted to show you how maybe you can put your data quality assessment, how to arrange it, and so on. Even in your organization, you see sometimes you can work under someone, they give you some kind of data that you don't have control over. It is always good to prepare such a report even if they give you a go ahead, if they cannot address the issues and maybe give you a go ahead to continue with the analysis, you analyze the data, but already you have given a report after doing assessment of data quality in preparation for analysis. So, as I said, my sessions are always brief, but now I want to give you an opportunity to ask questions before we wind our class. Yes, Tracy, you can just ask.
Thank you, Xavier. I wanted you to make some clarification on the difference between the accuracy and the relevancy. This slide see the relevancy.
Okay. The difference between accuracy and relevancy. So accuracy, like given for this example, like for instance, the customer demographic, if the age column, for instance, it was supposed to be there and it was not included, it means that data is not accurate. And transactional data, for instance, the profits column was supposed to be there and it was not included. When we come to relevancy, like the default column was not relevant, because relevancy means that like you have data that has columns that are not necessary or are not useful for your analysis, then that means it is not relevant. Sorry, it's not relevant. Another one maybe if you have outliers, like for instance, let us say in our class or in our session, I'm sure there's no one, if I find out that in your date of birth, I have someone who was born maybe in 19, maybe 50s and so on, I can, in most cases, you find out that that is not relevant. It is most likely to be an outlier. So I need to remove it because it does not assist me uh, um, in terms of what do you call? It does not assist me in my analysis. So that's the main difference between accuracy and relevance. Accuracy, you find out that yes, there's an important column that you need, but it is not there. It needs to be included, then your data is not accurate. But relevance, you can find yes, those observations are there, but they are not important, like useful for what you need. And in most cases, you find that they are outliers in your data set. Is that okay?
Yes. I've got another question from that one, talking about the accuracy. How do you find out that this column had to be here? Like, is it from the definition of the program? Like, from the definition of the program, you can imagine create some of the columns that you need to have, and how to get the real character that you have.
So it's okay. Thank you, sir, for that. So when you are given data, you are someone who gives you data needs to define all those columns and so on. So if they have indicated that, or based on the problem that you have been given, you find out that the age column is necessary for you to proceed with the analysis of the profits and it's not there, then it means that it is not accurate. So it is based, that one is based on what the problem that you have been given to solve, or for someone sharing the data with you, they have mentioned it, but it is missing in the actual data that you have received. So you don't, it is not about imagining or brainstorming. It is based on the information provided. I hope that is clear. Okay. Other questions? Other questions? Elizabeth? Yes. The difference between a database and that. Okay, thank you. So a database is where data is stored, but a data set is just data. Like later you learn on what called a data frame. Like data stored, it has, maybe if I have your records, that's a data set, and your records now, that your data set or your records can be stored now in a database. So database is where we store, but a data set is the actual data. Then the other question, I have explained that it has escaped a bit. Please come up again. Oh yeah, I have. Yeah, thank you. I have remembered. Yes, in organization, sometimes you might require to do something and you don't have data. So we do have what called data mining. Sometimes you can mine this data. You learn later over the internet. It depends with the problem that you are solving. Then there's what called transfer learning in machine learning. Like I use what has worked somewhere else to come and experiment in another industry. And so all the data from that has worked in another country and try to implement it is called transfer learning. So sometimes it is true that you won't have the data available, but you can mine this data. You can use case studies from other areas. However, it might not be very accurate, but now you use what called transfer learning to it assists you now maybe to experiment with that time until now maybe your model and so on gives you the right predictions based on now the available data in the organization. Is that okay, Elizabeth? Okay. Melas? Yes, I can hear you, though from a bit far. Yes. Yes. Okay, thank you so much. On the issue of data engineers and scientists, we are coming there now because that's the next thing that we are going to look at, how again the role of now the data engineers and so on. But it is good you have brought it earlier. But in this case, mostly, suppose you have been given data. This data you don't have control. Maybe this organization, even they don't have data engineers and so on. You have just been given data to analyze. You see, you cannot start solving based on assumptions. First of all, you have to do a data quality assessment and go back to the customer or the client. When you go back to the customer or the client, they now advise you, maybe if that data or information is available, yes, you can proceed with, they can provide. And if it is not available, they will advise you. And now, as a data scientist or a data engineer, you will know how you can deal with them, and of course, include that in your report. But now, later, next week, now, since on Fridays we don't have classes, we will learn. Um, we will learn. We will learn like how data engineers and data scientists can now assist in that. Maybe is that question well answered, Melas, before I go to the next? Okay. The next one is that for something to be considered as big data, must it meet all those characteristics like velocity, voluminous, and so on? Not really. It can meet some and not all, because there's something we talked about. I can have one image, for instance, which is unstructured kind of data, especially when I'm doing, maybe you are trying just to practice on what called computer vision and so on, like facial detection and so on. You see that a single image is not such a large kind of data, but it is unstructured kind of data and so on. So it is not a must that it meets all the characteristics, but those are the most associated for you to identify. Because, for instance, let me give you an example. Excel currently, I haven't, of course, confirmed recently, it has a limit in terms of number of rows that it can handle. If you have data which is structured and it fits exactly, then it doesn't mean that's big data. But if it doesn't, it means you have to use what call power queries, a functionality and add-on in the recent versions of Excel, because now the data cannot be analyzed using the normal Excel. You have to use add-ons, and then it becomes big data. So it is not a must that it meets all, because there is no actual measure to tell you that this is big data. There's no industrial standard kind of measure to tell you that this is big data or not. Yes, Melas? Okay. Any other question as we are winding up? Yes. Yes, I can hear you clearly. Oh, I didn't show that. Okay, thank you. Okay, okay. I thought I showed. That's noted. I'm just going to show it right away. Yeah, sorry for that. It means I forgot. Yes, maybe we can have the last question so that I can show that as we wind up. Yes.
So I would like to know again how this effect is going to help. Okay, that is one. And in most of the cases, the output that will have the function that we need of the inputs. So side of the input and the output doing the same standardization and how this is going to have an impact, positive impact between the input and
Okay, thank you so much. I'm not going to go very deeper into the standardizations currently because you are yet to start machine learning, but the importance, the impact of doing the standardization is to improve the predictability and accuracy of your model. Because if you have an imbalanced kind of data set, it means most likely that your predictions will not be accurate. So standardization mostly it uses mathematical kind of formulas and so on to do so. So the purpose, it just improves the predictability of your model. But you will see it practically as you proceed further with the curriculum. But that's the main purpose, just to improve, to ensure that your model is accurate in terms of predictability. That's the purpose of standardization, the most important aspect of it. Of course, we have other methods apart from standardization that can be used the same, but you will have that in machine learning. Is that okay? Okay. So let me show you. You wanted a sample, the practical. As I said, I don't have the multiple choice one because it's computer based. Where is it? Yeah, let me share. So this is a sample of how the project exam looks like. You have the title of the project, then you have the instruction, like the project scenario are not based on actual organizations, and any similarities to none are coincidental. Then you are being told to read the project scenario. Sorry, is there a question? Okay, I'm not going to the technicalities currently because you will come there. Sometimes what happens when you train people the introductory unit and you go to technicalities, people get scared earlier. That's why we try to allow the learning to be a bit spiral mailers so that we don't confuse people. But I'll answer it. I'll answer it. Let me first of all finish on this. So, uh, so that's a sample project, how it looks like. And you have been told how the grading looks like. You can score an A plus up to C. Another thing, you have been given the duration is normally 14 days. 14 days. Then, of course, you will be given the submission, how to submit, and so on. So, you are given all that story. you are given all that story, like a lot of, like you are given what happens in an organization. After that, you have the insights that you are expected from the project. Then, of course, if you go through the insights, there's a data set you are given there. After the data set now, of course, you know what you are supposed to uh, uh, do. There's submission guidelines. So you have the guidelines there and so on. Yeah. So that's how it looks like. I hope that is satisfactory. I can share this with you so that you can have a look, though it is still early. The next question is the one that Melas has asked, though it is very premature because we have not even gone through the, sorry for that, we have not gone through the statistics class, but we try to avoid based on the experience. Sometimes people get confused early, but let me just answer. When we are talking about normalization, mostly, you see in data science, we have what called futures. When you are building a machine learning model, futures are just like variables. So they are used to transform those variables to be on a similar scale. Like, but there's a difference between normalization and what you call, like mostly in normalization, you look at the minimum and maximum kind of scaling and so on. So in standardization, you will learn later in statistics, there's something we call the Z-score normalization and so on. So you transform now these features by subtracting the mean from what called the standard deviation, or what called the Z-score and so on. So this one mostly is very important when we are doing standardization. The assumptions made that your data follows a normal distribution. A normal distribution, like, how can I explain in a layman's language? Hmm. Like a normal distribution, I'm trying to look at how to explain. A normal, maybe let us say in a population, you are going to maybe do a survey in a population. So when you are doing a survey, you assume that your population is normally distributed. Like when you are going to do the sampling and so on, the assumption that when you are going to pick your samples and so on, you are going to pick a representative of the population. Like your sample is the actual that's representation of the population. And in most cases, normalization, when we go down to machine learning, we use when the variables are of different scales. And standardization, we use it when we want to ensure maybe the mean and the standard deviation are, you have a unit mean and standard deviation. But as I said that we are going to, you will just get it after the statistic class. When now we move to machine learning, it will be a walkover. It won't be technical as I'm explaining now. But we are coming there as we say that the curriculum is spiral. So maybe another thing before I wind up, I don't know if you have followed the recording. I hope they are audible enough. Is there anyone who followed yesterday's recording? Okay, maybe you can confirm later and let me know. So also notes, in case you did not receive the notes, you can as well inform me via inbox or email. I can reshare once more because there's some emails that were failing. Maybe I'll reach out to you, mailers. There are some emails that were failing. I'll reach out to you separately. As I was trying to send the the notes, I got some were not delivered. So thank you all for attending today's session. I hope you have learned a lot. We meet on Monday, same time as we progress with the curriculum. Thank you all. Have a nice weekend ahead. Tomorrow is a Friday, of course. Our weekend starts tomorrow. Yeah, I can share. I can share it, Javia. Okay. Maybe Melas, we can remain for a minute, just a minute if you have time. The rest you are allowed to leave. Yeah, just a
Thank you.
minute.
Have a wonderful weekend, everyone.
Okay, thank you. Maybe Stella and Joseph, you're allowed to leave. That's Joseph and Stella, you can leave. I want just remain with Melas. Stella and Stella, maybe you can leave. Okay, thank you. Melas, yeah, there are some emails that you shared for your team. Yeah, so I think some bounce back, or unless you shared other ones, maybe I can check. For the emails that she shared, yes. To some data and dancing, I need to talk with my team